In this section, we're going to make sure that you're set up and ready to go for all the different sections of the course. So that means setting up your Python environment and making sure that you have any necessary software and that you have all the resources you need. I've made sure to use only software that you can download for free and that works across multiple platforms. So whether you're on Windows, Mac, or Linux, these should work across all of them. I won't go into step-by-step detail of how to install all these because these things do change over time. So what I'm going to do is just point to the right resources for installation, and by the end of this section, you should have everything you need ready to go. In this section, we're going to make sure that you're set up and ready to go for all the different sections of the course. So that means setting up your Python environment. In this section, we're going to make sure that you're set up and ready.
problems in my right now is weeds. Since I live in Texas, these weeds tend to pop up year-round. And right now, there are basically two options for people who want to remove weeds from their yards. They can either do it manually, which not many people want to do because it's hard work, or they can use an herbicide like Roundup. Unfortunately, Roundup was recently implicated for the second time in causing a man's cancer, so that's not a great option, not really something that I want to do and put on my own yard. So I'm kind of envisioning this third option, and the third option is this awesome future where we have robots that can move around in our yards, or maybe attachments to tractors that can dig out weeds for us, but in order
workforce. So that means setting up your Python environment and making sure that you have any necessary software and that you have all the resources you need. I've made sure to use only software that you can download for free and that works across multiple platforms. So whether you're on software and that you have all the resources.
to do that, we're going to need something that can detect those weeds. So I wanted to see if I could create a synthetic data set using my method that I've been using for a few different projects, train a neural network to detect those weeds in video feed, and then hypothetically in the future when this robot exists or this attachment exists, use this neural network to spot weeds and dig them out. In order to create my data set, I walked around my backyard and front yard and took pictures of the ground. And I ended up using 37 of those as real background images. Then I walked around my neighborhood a bit and I found weeds in other patches of grass and took pictures of those and cut them out so that they could be composed over top of the backgrounds. And so then I was able to use code, Python code, to compose those and create new images that are not real, but are actually a composition of those background photos and the foreground cutouts of weeds. And you can see that some of these look a little bit fake, but others look very convincing. And either way, I figured they probably would work all right for training the neural network to find weeds in images, regardless of the background. I created 11,000 of these synthetic training images. In terms of time, took me about 30 minutes to take and organize the photos that I used, about 30 minutes to prepare the 37 background images I used, about 2 hours to prepare the foreground, so that means cutting out those little weeds, and 2 hours was about my limit. When I started to get really tired and wanted to stop. So it took me about 3 hours total of manual time to create this data set. And then for automated time, meaning I didn't actually have to do work to do it, I just had to kick off a few processes that would do it for me. It took me about 4 hours and 50 minutes to generate 10,000 training images, 30 minutes to generate another 1,000 validation images. But that was able to happen in parallel. And after I had the data sets created, I was able to train the MaskR CNN to a pretty good, impressive results. maybe on average 2 minutes per image, multiplied that by 11,000 images, that would take 366.7 hours. So this is a massive time savings, and really for a solo developer like myself, it really isn't even possible. This would take me months of manual effort to do, and there's no way I would finish it. I was really pretty stunned at how well it did, especially when looking at a video of it. And when you do individual frames, you can see that it sometimes misses parts of weeds, and you can kind of see that here as it's a bit shaky. Sometimes it picks up some false positives here and there, but from frame to frame on average, it picks up these weeds incredibly well, and it's very good at segmenting them. So I think some amount of averaging and maybe just increased amount of training would work really well. And the confidence on these weeds is super impressive too. Some of these, it's 100% positive that it's found a weed and it's correct. And it rarely seems to actually have false positives too. So overall, I've just been stunned. These videos are not running in real time. They're actually running with, I processed them offline and then we're watching them real time. So to do this in real time, you'd probably have to not do this so fast or choose another neural network or give it a lot more processing power than my current computer is able to provide. If you're interested, let's talk about what you need to get started with this course. So the first thing I recommend that you get is the CocoaSynth repository. And remember, all of these links I will provide in the course outline, so check that out. I won't try and read them off to you now. So this is the directory that has all of the code, all of the Python code, all of the notebooks, everything that you'll need, everything that's mentioned inside of this course. Then you will need Anaconda. So I'm using Anaconda to manage my Python environments, and I highly recommend you do so unless you know what you're doing and you have some reason for doing it otherwise. And if that's the case, then you're probably ignoring what I'm saying anyway. So if you're not ignoring what I'm saying, then do this. Anaconda just makes things a lot easier in my opinion. So I'm running this on Windows, but it works on Mac and Linux, and that should be true of the rest of the course as well. I've tried to keep it platform agnostic. Every bit of software is free, open source, and should work across all platforms. So I downloaded this Python 3.7 version and got set up. Now there will be some resources provided as well, a link to some instructions if you've never used Anaconda, how you can get started with it, create new environments, that sort of thing. I'm using Visual Studio Code, which I find to be one of the best text editors out there. It has lots of plugins for Python syntax highlighting and things like that. So again, this is supported on multiple platforms. I'm doing Windows, but you can pick your platform and use it on that platform. Then we're going to use GIMP. GIMP is image editing software that's free. You could use Photoshop for this if that's more comfortable to you or something else, but because this is free, this is what I have. I don't pay for Photoshop right now. Then you will need, for the later part of the course, when we are done creating our test data set, our synthetic data set, and we want to actually train a mask RCNN, you're going to need the Matterport mask RCNN repo. And we'll go into this in a lot more detail, but you can just download this repo and start by just familiarizing yourself with it. There's some really great documentation in here and some demos, so you can get an idea for how it works and make sure that you can get it working with just their stuff and not with the stuff we're going to add on, because you never know. Sometimes something is a little broken at a different layer and you don't want to add complexity to it. In order to run this, I used TensorFlow GPU, which is required. You at least need TensorFlow. I don't know for sure that you need TensorFlow GPU, but that's certainly going to speed things up if you have a GPU on your machine. So I have the installation page up here for TensorFlow GPU support, and that's going to look something like this: pip install TensorFlow-GPU. But I will point out, this part's kind of tricky. You have to install a number of software requirements before this works. And of course you need to have a NVIDIA GPU with CUDA compute capability. But you're going to need to install the CUDA toolkit and the CUDNN SDK. It says you need this, but I didn't install it, so I'm not sure if it says it ships with the CUDA toolkit, so that's probably why I didn't need to install it separately. I'll go into some detail later in the course, but you will need this stuff once you get to that step. And just know it's a little frustrating, but I believe in you. You can get through it. Just follow exactly what they say to do. Make sure you have exactly version 10.0 and 7.4.1. Otherwise, things will get a little wonky. Oh, and that's only if you're using TensorFlow 1.13. So it's specific, but like I said, you can figure it out. I believe in you. And then finally, some data sets that you may need for the course. One actually is completely optional, but it is the original Cocoa data set. And that's got images like this, where there's an object that is selected and labeled. And the biggest problem with this is that the data sets, if you go to the download page for it, are very big. So the instances, the annotations themselves are 1/4 of a gigabyte. That's not too bad, but the images, so let's see, the training images, 2017 training images, 18 gigabytes. So it's pretty huge. This part's optional. If you want to download it and browse through it, I highly recommend that you do the val images, which is only 1 gigabyte, and then use the val annotations to compare that. For the course, though, I won't be really going into the COCO dataset because it's so large and unwieldy. We're going to be working with a much smaller sort of test dataset that we create ourselves. And I'll provide links to these in the course outline, just like everything else. But it's going to be a box dataset by hand dataset and a box dataset synthetic dataset, and those will contain the stuff you need to get going with this data set. So once you have all of these things, and really for the first section, if you want to just get started as quickly as possible, the minimum you need is the code repo, the CocoSynth code repo, the Anaconda, Visual Studio, and GIMP, and then you'll be on your way. When you get to the mask-RCNN portion, you can continue with the rest of it. Is going to allow us to, I'm going to give you a high-level flow of how this course is going to proceed. So we'll start with the COCO Image Viewer Jupyter Notebook, and this is going to allow us to open up a COCO instances JSON file and view information about the data set and licenses and categories, and also open up an image and look at what the segmentation information is, outlines and shaded in colors for each object that's in the photo. After that, we're going to take images like this one and manually create masks with GIMP. And those masks will look something like this. Each object in the image will have its own color, its distinct color, and then these will have a definition file that describes what those colors mean. Then we're going to take that information and learn how to use this COCO JSON util script to convert it into real COCO instances JSON. So this is a hand-created data set that is then converted into COCO. So as you can see, there's some information about the data set first, and just like the real COCO data set, we have a list of images with licenses, file names, and then the annotations within them. And you can see that we've converted that mask into a list of vertices that outlines the outside of the object. So in this case, this is a list of vertices that is surrounding this object. So that's what we're creating there. It also contains the category information of what's inside the data set. Now, we don't want to create this by hand, so the next step is going to be learning how to use GIMP to cut out foregrounds like this. We'll take images, real images, cut out the backgrounds and make them completely transparent and prepare them for pasting on top of backgrounds randomly. And that's going to look like this. So I'm going to show you how to use the image composition Python script and walk you through each part of that, and show you how you can use it to place these objects, these foregrounds, randomly, and they're rotated and scaled, and the brightness is changed a little bit to create this set of synthetic images. And we'll ultimately be creating tons of these so that we can train our neural network to spot them no matter what the background is that we're working with. And then finally, we're going to use those training images as well as the COCO that's created along with it, and we will use this mask-RCNN training and inference notebook, and we will train using our training images. We'll have about 2,000 of them, and then another 300 for validation. And then after we train, we're going to be able to run it on test images. And here are some examples, just so you can see that we're detecting these boxes that we have in our data set with the neural network. And so I will be taking you through each step and walking you through each section of code and each command that you have to run. And so by the end of this, not only will you have the knowledge and potentially your own custom data set. If you choose to do that rather than just going with the example I give, you will also have a trained image recognition mask-R CNN that can recognize objects in your image with high confidence, and then you can use it for whatever you'd like. So this repository
Let's talk about what you need to get started with this course. So the first thing I recommend that you get is the Cocoa Synth
Let's talk about what you need to get started with this course line. So check that out. I won't try and read them off to you now. So this is the directory that has all of the code, all of the Python code, all of the notebooks, everything that you'll need, everything that's mentioned inside of this course. Then you will need Anaconda. So I'm using Anaconda. I won't, and that. Let's talk about what you need to get started with this course. So the first thing I recommend that you get is the Cocoa Synth repository. And remember, all of these links I will provide in the course outline. So check that out. I won't try and read them off to you now. So this is the directory that has all of the code, all of the, you will need Anaconda. So I'm using Anaconda. To manage my Python environments, and I highly recommend you do so unless you know what you're doing and you have some reason for doing it otherwise, and if that's the case, then you're probably ignoring what I'm saying anyway. So if you're not ignoring what I'm saying, then do this. Anaconda just makes things a lot easier in my opinion. So I'm running this on Windows, but it works on Mac and Linux, and that should be true of the rest of the course as well. I've tried to keep it platform agnostic. Every bit of software is free, open source, and should work across all platforms. So I downloaded this Python 3.7 version and got set up. Now there will be some resources provided as well, a link to some instructions if you've never used Anaconda, how you can get started with it, create new environments, that sort of thing. I'm using Visual Studio Code